Note that constructors, destructors, getters, and setters are four common paradigms for designing methods, but it's certainly not an exhaustive list of every type of method we could create. We could actually create methods to do whatever we want. And in fact, if we were really designing a bank account class like we were designing here, we probably don't want a set balance method. How often do we just wipe out the previous balance and set it equal to a new value? That's not the way we usually use bank accounts. Usually we use them by making deposits and making withdrawals. So here I've revised our bank account class to get rid of the set balance method and instead have a method for depositing money and a method for withdrawing money. Instead of just changing the value of balance to whatever is put in, it adds or subtracts that value. They still persist that same logging though, and I've temporarily truncated our log method just so that I can fit everything on the screen. But really, its contents would still be here. So down here in our main code, creating a new instance of bank account and setting it equal to the variable named my bank account will still trigger the same logging statement, account created. But now instead of setting the balance, I'm going to make a deposit. I'm going to deposit $20. That kicks execution up into the deposit method, where my balance is set equal to itself plus that amount, and then it logs both what was added, plus amount, and the new value. So here, plus 20, and my new value is 20. And then check my balance at 20, and it confirms and logs that my balance was checked at 20. And I print the results of that check, which prints 20 to my output. Then on line 27, I call my bank account.withdraw 10. That kicks execution up into the withdrawal method. It sets my balance equal to itself minus the amount, and it logs that. It logs that we subtracted 10, and that the new balance is 10. 20 minus 10 is 10. And then finally, we check it once more, which both causes balance checked at 10 to be logged and 10 to be outputted because we're printing the result of my bank account.getBalance. So now we've created a somewhat realistic class to contain the way a bank account is actually used in the real world. And what's particularly notable about this is that it mimics the way we think about real bank accounts. We think about them in terms of deposits and withdrawals. And so we named our methods for depositing and withdrawing, deposit, and withdraw. The power of object-oriented programming is its ability to let us write programs that mimic our own understanding of the world. We know that a bank account has a balance, the ability to deposit into it, and the ability to withdraw from it. And so our bank account is structured according to our knowledge of that real-world idea.